Good morning. This talk is Faro. The idea is presenting Faro. That is not a new language, but it still is a minimal, pure object-oriented reflected language that is quite small in itself, but it's very powerful because on top of it we have created a lot of things. This talk was intended to be presented by Stefan Dukas, but I am not Stefan Dukas, sorry. He has a problem with arriving here with the trains in France. We are in the middle of a really big strike that is not a problem at all, but sometimes makes the things a little more difficult. Well, I am Pablo Tesone. I am one of the engineers working in the Faro consortium. Basically, I am working also in the development of Faro with Steph, so I want to present it. I think it will not be the same, but I will do the best that I can. Well, Faro. What is Faro? Well, Faro is a Smalltalk inspired language and environment, and it's not new. But this question is always, we have it. Why to use Faro? Yes, Faro. Because for us, the most important thing, and the thing that we want to share with you, because we see that you are also a language enthusiast and you like a lot the simplicity and the elegancy of the language, is that it's elegant. And it's a really small syntax. We can write the syntax in a postcard, and it has a simple but powerful object model. This is the whole syntax of Faro. Sorry if some of the details will not be able to be seen, but this is it. This is the full syntax. We only have this, and with this we have a pretty nice object model on top of it, basically a dynamically typed system where everything is an object, everything is an instance of a class, and the class also are objects. Also, we have our all methods are public. We don't have the idea of private methods. They are virtual, so they are automatically executable from the subclasses, and we can have override without caring at all. All attributes are protected for us, and we are using a single inheritance, and with a small asterisk there that I will talk later. Faro is fully written in itself. All the code of Faro is bootstrapped from the sources. Even the virtual machine is mostly written in a subset of Smalltalk, a subset of Faro, and we can modify everything in the language itself in the runtime, even during we are executing it. So it's so flexible to change or improve it, or even destroy it. Faro also is highly immersive. What we want to say with this, that in Faro, nothing is a black box. You can check the code of all the methods, modify them, and improve it or do it worse. But the important thing is that we can always learn from that and get new ideas. It's fully inspectable. We can check all the objects in the image, all the objects in the memory, and we can change them, and they have a lot of reflective API to modify. Also, you can interact with all the objects, and classes and methods are also objects. You can take a class and inspect it or modify or send messages to modify it in your program and doing nice reflective things. As I told you before, we only have objects and messages. It's a real pure object-oriented world. And everything that we have in the system are based in objects. And we use a lot the polymorphism to implement the stuff. For example, if we want to implement not, we have false not, it should return true, and true not should return false. We let the receiver decide. We will use it doing polymorphism. So, for example, we will have three classes, one for the whole booleans with the common behavior, but one for false and one for true, because as every object, even true and false, are instances of a class, the behavior of true and false and in their respective classes. And this is the implementation. And this is not just a theoretical thing. If you check in the system, if you inspect the methods and check the source code of them and to modify, this is the implementation. So with this not much concept, we have a very powerful language and environment that basically it does not have a lot of the things that we see in many object-oriented languages or mainstream object-oriented language. Because, for example, we don't need the idea of constructor because basically a constructor for us is sending a message to a well-known object, usually a class. Or, well, we need a no-type declaration as is a dynamically typed language. We don't need interfaces or type factories or different solutions, well, because of the type system we are using. The idea of having different visibilities for us is not important because basically we want to give the power to the developer, and if the developer wants to send a message, should be able. At the end, is the responsible or not for breaking or making the things work. Also, a nice thing that we have in Faro is that as we have everything as an object, we have the idea of customizing the representation of objects and have nice inspectors on top of it. Basically, what we can do on many on all the objects is that we can execute code directly interactively, and with this see the different results. And for example, we can take and re-implement how every object is visualized, and it's so easy of doing this that we can, for example, integrate with a powerful visualization framework that we have that is called Rosal. And we say, okay, for this object, we will represent it in this way, or we will have it represented as an array. At the end, the matrix Q is an array of arrays. But we can implement it in more beautiful things. Or for example, if we inspect a directory, there is an easy implemented way of presenting it as an explorer of this directory. And for example, if you inspect one file reference that is an image, it just shows the image in the inspector. This also goes for all the objects that we have and objects that are not usually accessible. For example, in this one we are inspecting a method from a method dictionary in the class, one of the methods that will execute when we are executing or sending messages to instance of dice handle. So they will have this implementation of plus. From the compile method we are inspecting, we have many views, but one is to see the AST node. And as this is an AST node, someone has took the time and say, okay, I will do an extension, but every time you are inspecting the AST node, I will provide a new view that just shows the source code of the method and highlights the node that you are selecting. This gives a lot of power to open the system and create new visualization and new tools in an easy way. Because as we are developers, we think a lot about how to have faster development process. And one thing that I really love of Faro is that it's a live programming environment. You can basically develop in the debugger. This is our base debugger, where you can execute code and do debugger stuff, but also you can come here and modify this method, and once you modify the method, it will recompile the method, and you can restart the execution from there. If you recompile the method, of course, it will restart from the beginning of the method. It will not do the analysis to see the changes and restart in the middle, but it's powerful enough to do a real nice TDD experience, because you can really create the test and let all the other methods empty, and you start debugging it and you provide the smallest solution possible. A nice other thing that we have is that this debugger is basically as moldable as everything else in the system. So for example, one of the users of Faro has implemented using the same debugger, a debugger that this is a language called Vienna, if I remember well, and they have implemented an interpreter in Faro, but debugging the interpreter is boring and takes a lot of work, so they have created a debugger on top of the debugger to debug the language of the interpreter. So this ability to create new tools and to inspect objects, we can do it not only for developing the Faro itself and tools for Faro, but also we do it, or we try to sell to you and to everyone, that live programming can be something that we can do everywhere, and we can do it in web apps, sockets, application using sockets, IoT applications, and anywhere. And basically, our goal as a community is generate the tools or generate the small layers where you can invent your own future, or you can provide new business ideas or new research ideas and produce innovation and produce new nice things of that. Basically, we are aware that, or we want you to make a successful life of programming in Faro and be also fun of it, or both at the same time. And the idea is to provide a powerful language and environment where we can do innovative things. To that, one of the things that are more, to me, is more produce more proud is the community of Faro. We are a really nice community. Faro and all the tools are used by a lot of research groups all over the world, a lot of different places from Latin America, in the North America, in Africa, in Asia, a lot in Europe, but all over the world, and it's very, very nice to see that. We have a lot of teachers giving classes, object-oriented introductory course, advanced reflective course, and different, usually object-oriented courses in Faro all over the world. So it's very nice. Also, these different professors and all the community has produced a lot of open source books that are available to anybody to download, to produce new content, to take it, destroy it, do whatever they want. Also, we have a very nice tool that is an open MOOC. It's not only available for everyone, but also it's open source. You can access the videos, you can access the presentations, the material, whatever you want. You can change it, you can use it in your lessons or just for fun. One nice thing that we have, and now is more active, usually here used to be a slide talking about the mailing list, but now the mailing list is so far away, because the nice things happens in Discord. There is much more nicer communication where we interact more dynamically, and it's very, very nice. And it's a good place for beginners and also for experts, and just to talk on, and sometimes only to hang out. Also, we have a set of different publications that we try to do almost regularly. It's difficult because it takes time to do things nice, but we try to continue producing material all the time. Basically, we are not alone in the world. Basically, all this is part of a big community. We have a lot of companies and universities and research institutes that they are using Faro, some to produce pure research, some to produce applicated research, but also a lot of companies that they use Faro because it's good for their productivity. We have a lot of many success stories, but it will take a lot of time, and from commercial applications or to research applications for mobile, for applications on IoT, or simple web or complex web applications, as you want to see. The most important thing for me is that Faro, it's open, it's available, you can use it, you can hack it, you can break it, you can do whatever you want. Basically, to me, it's very addictive, but maybe you like it or not. Well, we have all our source code in GitHub. You can check all the things that we have there. It's always bootstrapped from the code, and we have an ICI process that is trying to build all the time Faro from scratch and see when we break it. So, well, this is all my presentation. I hope you like it, and well, I'm open to questions, and if not, you can pass through our stand in the K building, and we can talk longer and take coffees or beer.
We have a few minutes for questions, and the next speaker can also come and set up.
Yes.
So one thing I'm wondering about is the bootstrapping problem. Where, for instance, when you say, okay, if I have integers, then every integer is itself an object. And if I do addition, then I send a message to that object with the other object that you add to it as in the information of the message. But at some point under the hood, you really do want to add those two numbers on your actual computer.
Well, actually, yes.
How's it solved?
The question was how it solved the problem, for example, when adding two different integers. At the end, someone has to execute it in the machine and produce the sum. Basically, what we have is, as many other languages using virtual machine, we have at the end a layer of primitives. We try that this layer of primitive is the smallest as possible, but for example, adding two integers or adding two floats, we will require to have a primitive. The same when we want to send a message, for example. We try to reduce it, and even in some of the cases, when we have primitives, you can check the code and you see the fallback code. Because, for example, for adding two integers, it can be done all in Faro. It's many orders of magnitude slower than doing directly, but it can be done. So you can see in the primitive invocation the code, the Smalltalk code that can be replacing that. And the idea is also that with the time starting to see, okay, this primitive we want to show at least how it could be done in Smalltalk, or which is the equivalent Smalltalk code that should work.